Hello there, welcome back. We're going to solve the system 2x minus 3y equals 2, negative 4x plus 6y equals 14 using Gaussian elimination. So again, the first thing we're going to do is rewrite this system as an augmented matrix. So we have 2, negative 3, augment 2, negative 4, 6, 14. Now remember, the goal of using Gaussian elimination is to get the matrix in this form. We have 1s on the main diagonal and 0 in the lower left. The upper right-hand entry here can be anything, and the 2 numbers on the right can be anything, and that's going to get worked through as we do our row operations. So first thing we need to do is get a 1. Now again, I can't switch the rows because I don't have a 1 in the first spot in the second row. So what we're going to do is just multiply the first row by 1/2. So in row operation form, we're taking 1/2 of row 1 and making that row 1. So doing so, just multiplying the first row by 1/2, which remember is just like multiplying both sides of an equation by 1/2, completely valid operation. We have 1, negative 3/2, augment 1, and then negative 4, 6, 14. Okay, great. So now we're ready to get the 0 here. So the way we do that is we take 4 times the first row and add it to the second row. It's kind of like what I like to call controlled elimination, where we're focused on getting the first variable eliminated in the second equation. So we automatically know to multiply the first row by 4, because when combined with negative 4, that's going to give us 0. So 4 times the first row is going to be 4, negative 6, 4. And the second row is going to be negative 4, 6, 14. There's an augment there. And when we add those together, we have 0, 2 zeros, and an 18. Whatever does that mean? So this is the new row 2. Remember, row 1 is the way I want it, so I don't want to replace that row. So we leave that there. And now the new row 2 is 0, 0, 18. So it's impossible for us to get the 1 here. So where to go from here? Well, let's translate these back to equations. We have x minus 3/2 y equals 1. 0x plus 0y, which is really just 0, equals 18. And that right there tells us that we have a problem. This equation has no solution. There's no variables in it, first of all, and it's never true. In fact, this is what we call a contradiction. So that means that this system has no solution, because one of the equivalent equations is 0 equals 18, which is false all of the time, which means this system of equations has no solution. In fact, if you were to go back to the graphing method, if you were to graph each equation in the system, you would notice that you would produce 2 parallel lines, which have no solution in common. So there is our no solution using Gaussian elimination. And just so you know, in general, if you ever end up with this, where you have all zeros on the left and a non-zero number on the right, that's an automatic indicator of no solution.